Question 8. I'm going to square both sides. Now if I square root 10, I'll just get 10. On the left hand side it's root 2 times root 2, which is 2, plus 2 times root 2 times root 3, which is root 6, plus 3. And that's less than 10. So 5 plus 2 root 6 is less than 10. If I subtract 5 from both sides and then divide by 2, 5 divided by 2 is 2.5. Now, what I want to do is to multiply by root 100. That gives me root 600 here. And the root of 100 is 10. 10 times 2.5 is 25. Now, we know that, at least we should know that, the root of 625 is equal to 25. So the root of 600 then must be less than 25. So we want to find the y-intercept. The y-intercept always occurs when x equals 0. So y equals minus 0 minus 4 over 0 plus 1, which is minus 4. So we have the point 0 minus 4. X-intercept always occurs when y equals 0. So we have 0 equals minus x minus 4 over x plus 1. Now I can bring the 4 over x plus 1 onto the left hand side. Multiply by x plus 1. And that gives me 4 equals minus x plus 1. Now I have a quadratic equation in here. If I bring, so that's minus x squared minus x, and if I bring everything onto the left hand side, we have x squared plus x plus 4 equals 0. Now a quick calculation. B squared minus 4ac gives us 1 minus 16, which is minus 15. Minus 15 is less than 0. So there are no x-intercepts. Now, we know that x cannot equal minus 1 because that gives us a 0 on the bottom line. So we have a vertical asymptote then at x equals minus 1. So why don't we consider what happens as x tends to minus 1 minus and as x tends to minus 1 plus. So what we want to do is just to consider this part here, because the minus x at the start will become irrelevant for very large values of the second part, which is this whole fraction here. Now when x is to the left of minus 1, it means that the bottom line will be negative and that the whole term will be large and positive. When x is to the right of minus 1, it means the bottom line is positive and the whole term then is large and negative. Now as for the non-vertical asymptotes, what I have to do is just to well, the non-vertical asymptote is is this here, so y equals minus x. And what we can do is consider what happens to the function when we have very large positive and negative values of x. So as x tends to positive infinity, well, we have y tending to minus x minus from below. That's because of this negative sign here. So when x tends to negative infinity, y will tend to the asymptote, but this time from above. So we can actually make a sketch. Here's the line x equals minus 1, and here is the line y equals minus x. So to the left of minus 1 we have a large positive value. To the right of minus 1 we have a large negative value. And you can see what's going to happen. When x is larger than negative, which means in this direction here, we approach the non-vertical asymptote from above. So these two will join up like so. And when x is large and positive, which means in this direction here, we approach the non-vertical asymptote from below. So we have something that looks like that. So stationary points. Well, what I'm going to do is just to rewrite this as minus x minus 4 lots of x plus 1 to the power of minus 1. And dy by dx then is minus 1 plus 4 x plus 1 to the power of minus 2, and d2y by dx squared equals minus 8 x plus 1 to the minus 3, which we can write as, and this will be useful for determining the nature of the stationary points. So for stationary points, what we want to do is to set dy by dx equal to 0. So that's minus 1 plus 4 over x plus 1 all squared equals 0. And I'll split these terms up. That deals with the negative 1. Multiply by x plus 1 all squared. Expand the brackets, so that's x squared plus 2x plus 1 plus 1 minus 4 is minus 3, and this factorises to give, you already know there should be two stationary points, so it's 3 and 1 plus and minus. So I have a stationary point at x equals 1 and another stationary point at x equals minus 3. Now when x is 1, y has the value so it's minus 1 minus 4 over 1 plus 1 is 2, so it's minus 1 minus 2, which is minus 3. And then when x has the value minus 3, so y equals minus 3 is 3, minus 4 over minus 3 plus 1 is minus 2, so 3 plus 2 is 5. Now we could talk about the nature of the stationary points. When x has the value 1, d2y by dx squared is minus 8, which is less than 0, therefore 1 minus 3 is a maximum. When x equals minus 3, minus 3 plus 1 is minus 2, minus 2 cubed is minus 8, and minus 8 over minus 8 is 1, which is greater than 0. Therefore, minus 3, 5 is a minimum, and that fits in with what we already know. Now, it doesn't ask us to sketch the function, but I'm just going to do that anyway. Here's the x-axis, the y-axis. Here's the line x equals minus 1, the vertical asymptote, and this is the line y equals minus x, the non-vertical asymptote. Now, we have a stationary point at 1 minus 3, which is a maximum. We have something like this. And then at minus 3, 5, we had a minimum. And there is the function sketched. Now it's useful to see that diagram because the last part of the question asks us for the coordinates of the stationary points of y equals the modulus of f of x, which means this stationary point here is fine because that's above the x-axis. But this stationary point here has to be reflected above in the x-axis, so that becomes 1, 3. So the auxiliary equation is m squared minus 2m plus 1 equals 0. And that factorizes to give m minus 1, m minus 1, so m equals 1. So the general solution then is that y equals ax plus b e to the power of 1x. Now when it comes to the particular solution, you can see that we have b e to the x here and 10e to the x here. Now, what we might do is have a particular solution then multiplied by x. There's a problem with that as well because we've got an ax here. That's ax e to the x. So what I'm going to do then is multiply by c x squared for the particular solution. If I differentiate that, well, that's a product, so that gives me 2cx e to the x plus cx squared e to the x. And if I differentiate for a second time, so the product rule gives me 2c e to the x plus 2cx e to the x plus the second term, that gives me 2cx e to the x plus cx squared e to the x. So we have y double dash rather, minus 2y dash plus y equals 10 e to the x. So we have from the last slide 2c e to the x plus 2cx e to the x plus 2cx e to the x plus cx squared e to the x minus 2 lots of y dash. Now y dash is 2cx e to the x plus cx squared e to the x plus y so we need to simplify now. So I've got 2c e to the x plus 4cx plus cx squared e to the x On the second line I have minus 4 cx e to the x minus 2 so this term cancels out with this term. This plus this, take away this, gives us 0. And we've then got 2c e to the x equals 10 e to the x. 2c equals 10 and c equals 5. Now with c equal 5 we have the general solution then. Ax plus b e to the x plus 5x squared e to the x. Now what we want to do is to employ the information given. So when x equals 0, y equals minus 2. This will allow us to find the values of a and b. So minus 2 equals, well, this term is 0 and this term is 0, so we've got b e to the 0, which is just b. The second piece of information we have is that y1 equals 0. So when x equals 1, y equals 0. So 0 equals a x. Now we know that b is minus 2. E. X has the value 1, so we've got 5e here. If we take out e as a common factor on the right hand side, we've got a minus 2 plus 5. Well, a plus 3 must equal 0. So a then equals minus 3. And the final solution then is y equals minus 3x e to the x minus 2 e to the x plus 5 x squared e to the x. So, well, dx by dt is minus sine t plus, now this part here is a product, so we differentiate the first and leave the second, and we'll leave the first and differentiate the second. Sine t minus sine t is 0, so we've just got t cos t. Dy by dt, so sine t gives us cos t. Now this here is a product, so I'm going to put the minus there and then I'll have a bracket. So differentiate the first, leave the second, and leave the first and differentiate the second. Now that's cos of t minus cos of t plus t sine t, which is t sine t. Now dy by dx is dy by dt times 1 over dx by dt. So it's t sine t times 1 over t cos t. T's cancel out, we've got sine t over cos t, and that is tan of t. Now d2y by dx squared is d by dx, I beg your pardon, it's d by dt, dy by dx times dt by dx. So if I differentiate tan of t with respect to t, I get sec squared t. dt by dx is 1 over dx by dt, so it's 1 over t cos t, and that's 1 over t cos cubed t. Now we know that dy by dx equals 0 for stationary points, so we just calculated that dy by dx is tan t equals 0. T equals 0, pi to pi. So it does have a stationary point at t equals pi. We know that d2y by dx squared is 1 over t cos cubed t. Now when t has the value pi, we have 1 over pi cos of pi cubed. Now the cos of 180 degrees is minus 1. So minus 1 cubed is minus 1, and this whole term then gives us the value minus 1 over pi, which is less than 0. Therefore we have a maximum TP. Integration by substitution. What we're going to do first of all is, so dx by d theta equals cos theta. So I can replace dx then with cos theta d theta. Rather, I can replace cos theta d theta with dx. So we're changing from theta, a variable theta, to x. Now the limits, well, we know that theta equals 0, so x then equals 1 plus the sine of 0, which is 1. When theta equals pi by 2, x equals 1 plus the sine of pi by 2, sine of 90 is 1, 1 plus 1 is 2. So the integral becomes integral from 1 to 2. Now the top line, cos theta d theta, we can replace by dx. And 1 plus sine theta is x cubed. This is very, very easy. The ideal problem. So it's x to the power of minus 2 over minus 2 evaluated between 1 and 2, which is, well, we might want to write it as minus 1 over 2x squared. It'll make the substitution and evaluation a bit easier. So 2 squared is 4 times 2 is 8, so it's minus 1 over 8 minus 1 over 2. So minus 8 plus a half, minus an eighth plus a half is 3/8. So here we have a first order linear differential equation. What I'm going to do is to divide by x to get it into standard form. So dy by dx plus y over x equals sine of x. And the integrating factor then is e to the integral of 1 over x dx, which equals e to the natural log of x, and that is x. So we're going to multiply the equation throughout by x, and that gives us x dy by dx plus y equals x sine x. So right back to where we started. These two terms here come from differentiating the product xy. So when we integrate both sides, we get xy here, and the integral of x sine x dx. Now, we're going to have to employ integration by parts, so u equals x, u dash equals 1, v dash equals sine x, and v equals minus cos of x. So xy equals u times v, so that's x, times minus the cos of x minus v times du. So it's minus x cos x plus the integral of cos x dx. And that gives us minus x cos x plus sine x plus c. Divide the whole thing by x to get y on its own. So that's minus cos x plus sine x over x plus c over x.